In this demo, we will enable the EFS data volume to our ECS containers. This is the overall architecture looks like if we are adding EFS volume to our containers. Our task instances either created through service, or otherwise, will be connecting to the EFS file system, residing in your VPC. Request will be made to the load balancer, which will forward it to the tasks, with the help of target groups. When any of the task instances are writing, or reading any data, the respective requests will be made to the EFS system, with the help of configured data volumes. For our containers to use EFS as the volume, we will first create the EFS file system. We will create an ECS volume, referencing the already created EFS file system. At last, we will be creating a mount point, to mount the volume to our to-do app container. Also we need to establish communication from ECS task to EFS. This is done at two levels. First is the network level, where the network access will be established with the help of security groups. EFS security group should have the inbound access defined from the ECS task security group. Additionally, we need to define API level access. For this, the ECS task role, which is associated with the task instance, should have the EFS access policies attached to it. Alternatively, we can define the resource level policies with EFS system as well. For the demo, we are going to follow the first model, where the access policies will be attached to the task role. Rest of the components remain similar to our previous implementation. Now that we understand what we need to enable the EFS volume, let's implement our CDK code. I am on my local machine and on Visual Studio Code Editor. In our CDK app, I am going to introduce new stack, called as EFS volume stack. As you can see, it's created inside the lib folder. Let's go to this stack. As usual, I am extending the CloudFormation stack here. I have created the demo VPC here. And the demo ECS cluster. I am creating an EFS file system here, with the help of EFS.FileSystem module. AWS EFS is the module provided by CDK. I am creating the task definition here. Most of the part is similar to other implementations. Primary difference here is the volumes parameter. This accepts array. Inside this array, I am creating a demo EFS volume. I am providing EFS volume configuration with it. This is how ECS understands, this is an EFS type data volume. Inside this configuration, I am giving the reference of our EFS file system. In the authorization config, I am specifying to use IAM role permissions to check access on the specified file system. Also, I have enabled the transition encryption, which means all the communication with EFS system will be encrypted and secured. Please note that I am using Fargate task definition here. This is to simplify our EFS demo. As discussed earlier, EFS is compatible with both Fargate and EC2 instances. Now that the task definition is created, I can reference it to specify the task role policy. I am using grant method of EFS file system here. In this task role of the task definition is set as the principal, and I can pass the policies we want to associate with the role. I have put start here, which means all the APIs, but you can provide more specific API references, actions and conditions here. No change in the add container method, it's similar to other implementations. But I am getting the reference of container, getting created here. I will use this to specify our mount point, for the EFS volume. I am using add mount points method, where I am passing two parameters. One is the container path, where our to-do app container will update the SQLite data. Second is the source volume, where I am passing the demo EFS volume we just created. No change in ECS service. Load balancer. And the listener. Similar to previous implementations, I will use register load balancer to register the containers, and target groups, to the load balancer listener. Earlier in this demo, we discussed about creating network access between EFS and ECS tasks through security groups. I will achieve this by using connections method of EFS file system. In this, I can specify the source, which is our ECS service. I am specifying port 2049, where NFS protocol listens on EFS file system. We are ready with our code. Let's run CDK synth to see there is no error, and CloudFormation templates are getting rendered. Command is successful. There is no error. Let's deploy our CDK code. We will use CDK deploy command. The command has started. It's asking me to confirm the changes, which I did. The command will take some time to provision the resources. Let's wait for it to finish. The command is completed successfully. It shows our stack creation is complete. Let's check the resources which got created, as part of our CloudFormation stack. I am on my AWS console, and navigated to the CloudFormation page. We can see our stack here, it's in Create Complete status. Let's click on it. And then on Resources. Here is the list of resources created with our stack. Let's start with the EFS file system we created, which is the core focus area for this demo. Let's click on it. We are at EFS console. The file system state is available. This is the DNS name. If you click on the network, you will see 2 EFS instances have been created, across 2 availability zones. This is to ensure higher availability for the EFS system. Both are in available state. These instances are associated with the security groups. Let's check out this security group. Security group is an EC2 feature. We can see its details on the EC2 console. Let's click on it. And then I will click on Security Groups menu item on the left. I will search for the security group associated with EFS. Here it is. If you click on the inbound rule, you can see the rule we configured. It's allowing the connection for the NFS type, on port 2049, from the source, which is another security group. This security group is associated with our ECS service and tasks. Let's go to our ECS console, and check our tasks. Here is the ECS cluster reference. Let's click on it. We are on ECS console. The cluster is in active state. Here is the ECS service we defined. It's in active state. The deployment and tasks column is green. The last deployment status is completed. Let's click on the service. And tasks. This is the task instance created. It's in running state. If you pull up the details and click on volume configuration, you will see the mount point, which is referring to the demo EFS volume, and container path we configured. Here is the task definition. If you click on the storage, you will see the EFS volume we configured for it. We set the name as demo EFS volume. The root path is configured by default. This is path on EFS system our container will get linked to. This is the file system we already checked out. Also, as you can see, the transit encryption is on, along with the IAM authorization. This is how we configured the volume. Let's check the task role, to ensure we have sufficient permissions or not. We are on the IAM console. Here are the role details. If you click on the permissions, you will see the action defined here. With EFS file system.star. And the resources mentioned as our EFS file system. This is how we configured the task role policy. Let's go back to the ECS service. Here is the listener reference. Click on it. This will take us to the load balancer page. Let's go to our load balancer. Here is the listener defined at port 80 with the target group. Let's copy the DNS name, to check our application. Our application is accessible now. Let's do a sanity check. Application is working fine. To check if the EFS volume is working or not, let's stop the task instance. I am on the ECS console now. Here is the task instance's view. Let me click on the task instance and stop it. As you can see, the task is stopping here. Let's wait for it to finish. If we access the application after some time, you will see it has become inaccessible. Let's wait for some time, till our next task instance is created. Our ECS service will launch another task instance to replace this. As you can see, the task instance is started. It's in pending state now. Our application should be available any moment now. Here it is. We can see the application, and the total entries we created. Which means our EFS volume configuration with ECS is successfully working.